Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, we'll solve question number 5, NEET Physics paper 2015. Student, let us solve question number 5. For a parallel beam of monochromatic light of wavelength lambda, diffraction is produced by a single slit whose width is A, is of the order of wavelength of the light. If D is the distance of the screen from the slit, this should be slit. From the slit, the width of the central maxima will be. That means it is talking about if this is the slit with width is A is the width of this slit, and light is entering and falling on a screen at a distance d from the slit. We know that here I'll have when light enters, each point will behave like a point source according to Huygens principle, and the center will be having path difference of 0, producing central maxima, thereby a minima and maxima and alternate minima and maxima. Now the question is to find the width of central maxima. The width of central maxima means how far this central maxima is spreading along this line or this length. This length is known as the width of central maxima. This is the width of central maxima. Linear width, or we can also measure from the center of this slit what angle it produces. In any other question it might have this question also, it might be asked that this angle is the whatever is this angle, say alpha. This alpha is called as angular width of central maxima. This is the linear width of central maxima. So because within this angle only the central maxima is spreading into this angle. Okay. So the option is talking about linear width because here the unit is meter. You can see there are 3 lengths involved, so ultimately units will move to meter. That means it's talking about the linear width. Okay. From this linear width, whatever is that value, we also know how to find alpha. But okay, let us first find the linear width. How to find the linear width? If the central maxima ends here, then that is where the first minima will start. So that means the position of first minima here and the position of the first minima on the other side of the central maxima are equidistant. This distance and this distance same. So basically I have to measure the distance between two minima, first minima. Distance between two first minima is the width of the central maxima. Where the first minima is formed from the center of the screen, that is known to us, and that is called as x1. I call this as x1. Suppose this is formed here, then this angle is θ1, and this length, this is suppose x1, this is D and this is A width, we know that A sine theta n equals to n lambda for the minima. This is the condition, general condition for minima in case of a single slit diffraction. A is the width and theta n corresponds to the order of the minima. The first minima is here. Here also the first minima. Then it will turn and again the second minima and so on. Therefore n here is 1. If I put n is 1 over here, this is lambda. A sine theta 1. N is 1. Theta 1. So therefore I have written this is theta 1. This theta is very, very small. Because it's very, very small, I'll write this as tan of theta 1 for my calculations of the length. This x1 is the position of the first minima from the center of the central maxima. This length is x1 and we are interested to find x1. And the width is x1 this side, x1 this side, so total width is 2x1. That is the answer to the question. So to involve this x1, I consider this triangle, right angle triangle, and this is theta 1, this length is d. So tan theta I can write as x1 over d, which is equal to lambda. So from here I can write x1 is lambda d by a, x1 is lambda d over a, so 2x1 is 2 lambda d over a. So 2x1 is the width, rather linear width of central maxima, and it comes out to be 2 lambda d over a. And if it is to ask to find the angular width of central maxima, that means it's talking about finding theta 1 to theta 1. Then theta 1 is obviously lambda by a, that already we have got. This, in that situation, you can write this one. If angular width is asked, then from here you can write a theta 1 is lambda. So from here theta 1 is lambda over a. So 2 theta 1 will be 2 lambda over a. This is the angular width of central maxima, 2 lambda over a. This is the linear width, 2 lambda over a into d. So basic difference is d. So if in the linear width, if you remove this d, 2 lambda over a, that is the angular width of the central maxima. So 2 lambda a is the answer to this question. If I see that 2 lambda over 2 lambda d, 2 lambda d over a, 2 lambda d over a, so option number 3 is correct option, and that is the correct answer to this question. Okay, thank you.